right? So how do we sketch, put it all together, how do we sketch a rational function? Number one, we got a factor. Number two, find the intercepts, x and y. 3, vertical asymptotes. 4, horizontal asymptotes. 5, sketch it up, okay? All right, first step, factoroni, right? So I think you get 2x here, and x, and plus 4 and minus 1. And over here we're going to get x plus 2 and x minus 1, okay? Factored it up. Awesome. How do we find the intercepts? Well, let's go through that. I'm going to put it over here, save some room. So intercepts, let's do the x-intercepts first. When do the x-intercepts happen? Well, that means when my height is 0. Well, this is a fraction, right? When is a fraction equal to 0? That only happens when the numerator is equal to 0, right? So for example, I got a fraction, blank over blank, a over b. When a is 0, 0 over 7 is 0. So to find the x-intercepts, I set my numerator equal to 0, 2x minus 1 times x plus 4 equal to 0. That happens when x equals 1/2 or x equals negative 4. So my x-intercepts are 1/2 0 and negative 4 0. Okay? So I found my x-intercepts, not that bad. The y-intercept is probably the easiest thing that we do in this whole problem, because there's only going to be one y-intercept, otherwise it's not a function. And you plug in 0. Now you can do it here or here. I'm going to do it here because 2 times 0 squared plus 7 times 0, 0 squared plus 0. So I'll get negative 4 divided by negative 2, which is positive 2. So if I plugged in 0 for x, I got 2 for y. So my y-intercept is 0, 2. That's something we did mentally. Plug in 0 for x, find out what y is. Good. Here we plugged in 0 for y, right? And found out what x is. All right? So we've got these 3 points as my intercepts. Okay, fine. Let's talk about the vertical asymptotes. Vertical asymptotes are when we have our denominator equal to 0. So when it's x plus 2 times x minus 1 equal to 0, this happens when x equals negative 2 or x equals 1. These things are my vertical asymptotes, okay? Now, as x approaches negative 2 from the left, and as x approaches negative 2 from the right, we need to talk about. And we need to talk about as x approaches 1 from the left, and as x approaches 1 from the right. You need to always talk about these things. What does f of x approach? What does f of x approach? So we know since they're asymptotes, it's either going to be positive infinity or negative infinity. So all we really got to do is plug in a number really close to negative 2, but on the left side of negative 2, and see if it's a positive or negative number. So I'm going to use the factored form to do that. So I put a number that's to the left of negative 2, but really close to negative 2. Maybe I put in negative 2.01. Negative 2.01 plus 2 is negative. Negative 2.01 minus 1 is negative. Negative 2.01 plus 4 is positive. Negative 2.01 times 2 minus 1 is negative. Negative, positive, negative, negative will be negative. This is going to negative infinity. Okay? Now I'm going to plug in a number just to the right of negative 2. That's negative 1.99. Negative 1.99 positive, negative, positive, negative. We've got 2 negatives, so this is going to go to positive infinity. Okay? All right, now we approach 1 from the left. Give me a number real close to 1, but to the left of 1, 0.99. Okay, so that'll be 2 times 0.99 minus 1. Okay, that'll be positive. Okay, 0.999 plus 4 is positive. 0.99 minus 1. 0.99 plus 2 is positive. So this will be negative infinity. And it can be 1.01. That just turns out to positive. That's still positive. 1.01 times 2 is still positive. 1.01 plus 4 is positive. So that goes to positive infinity. Right? Okay, so we finished vertical asymptotes. Let's talk about horizontal asymptotes. I'll graph it up there. Horizontal asymptotes. We'll go back to my original function, top heavy, bottom heavy, or balanced. Degree 2 is balanced, so then I look at to get degree 2, it's balanced, therefore I look at the ratio of 2 to 1, the leading coefficients here and here, 2 to 1, so my horizontal asymptote is y equals 2. Do I ever intersect it, that horizontal asymptote? That's a good question. So do I ever intersect it? Okay, so then I say 2 equals 2x squared plus 7x minus 4 divided by x squared plus x minus 2. Multiply it over and I get 2x squared plus 2x minus 4 equals 2x squared plus 7x minus 4. Subtract 2x squared. Subtract it over, I get 5x. Add 4, I get 0. So x equals 0. So I do intersect it at the point 0, 2, which I knew that already, didn't I? I knew I hit that 2 value right there. I already knew that. Okay, so x-axis, y-axis, draw my asymptotes. So I've got 1 half 0, 1, 2, 3, 4, 1, 2, 3, 4. I've got 1 half 0 is a point on my graph. Okay, negative 4, 0 is a point on my graph, and 0, 2 is a point on my graph. My vertical asymptotes happen at negative 2 and positive 1. And my horizontal asymptote is y equals 2. Okay, so what happens here? As I approach here, negative 2 from the left, I go to negative infinity. I'm going to approach that horizontal asymptote that way. Okay. Okay, over here, we know these 2 points connect, but as I approach negative 2 from the right, it goes to positive infinity. Okay, it's going to come down, it's going to touch that, go through there. But as I approach 1 from the left, I go to negative infinity. Going to negative infinity, awesome. Okay. As I approach as I approach 1 from the right, I go to positive infinity. Approaching 1 from the right, go to positive infinity. And as now we're talking about my horizontal asymptote, I got to approach this thing. As x goes to infinity, I go to 2. Okay? So there's a sketch of the graph of this guy. All right? Okay, so another example of graphing. Same type of idea. First off, we talk about our x-intercepts and our y-intercepts. Okay, first factor, I get x minus 5, x plus 1 divided by x minus 3. Awesome. So my x-intercepts happen when the numerator equals 0. When does x minus 5 times x plus 1 equals 0? This happens when x equals 5 or negative 1. Okay. What about my y-intercept? That's easier in the original function. Plug in 0 for x, 0, 0, 0, and I get positive 5/3. So we put in 0 for x, and we get positive 5/3. So we have 3 points, 5, 0, negative 1, 0, and 0, 5/3. We've already got 3 points on my graph. Fantastic, okay? Let's talk about the vertical asymptotes. Vertical asymptotes. When does my denominator equal 0? Now, when does x minus 3 equal 0? That happens when x equals 3. So we have to approach it from the left, and we have to approach it from the right and see what happens. We know it's going to either go to positive infinity or negative infinity, right? As I approach 3 from the left, give me a number close to 3, but to the left of 3, 2.99. Minus 3 will be negative, plus 1 will be positive, minus 5 will be negative. This will be positive infinity. And then I give a number just to the right of 3, but approaching 3 to the right, close to 3, but to the right of 3, 3.01. Positive, positive, negative, so this will go to negative infinity. Okay? Vertical asymptotes are done. Horizontal asymptotes, this is where it gets tricky. We look at the degree. Degree of the numerator is 2, but the degree of the denominator is 1. So this is a top-heavy situation. So there are no horizontal asymptotes. However, when the degree of the numerator is 1 more than the degree of the denominator, then what we're going to have is something called a slant asymptote. Okay, so it will have a slant asymptote. Okay, so that's when the degree of the numerator is 1 more than the degree of the denominator. So if I add one of it, it's always 1 more. So what do I do in those situations? Well, the first thing is we're going to do long division to see what's happening. So I go x minus 3 into the x squared minus 4x minus 5 multiplied by x, and I get x squared minus 3x. Subtract downwards, plus, negative, plus. Okay, good. I get negative x minus 5, multiply it by negative 1, negative x plus 3. Okay, oops, wrong color, sorry. Negative 1, negative x plus negative x plus 3, there we go. Subtracting downwards, plus, plus, negative, makes this negative 8. All right? So when I divided these two, really r of x is equal to x minus 1 plus a negative 8 divided by x plus, minus 3. This function is really that function. Now, kind of put all this together. My points are 5, 0, negative 1, 0, negative 1, 0, 1, 2, 3, 4, 5, 5, 0. Okay, I know I have a vertical asymptote at 3. Awesome. Okay, I have a slant asymptote. I did long division. I note that this function is equal to this function. Okay, we did long division, that's what it equals. Now, for large values of x is a billion, negative 8 divided by a billion minus 3. That's basically negative 8 divided by a billion. This is 0. This is roughly 0 for large values. So really, if that's 0, this function really looks like, if you squint your eyes, if you zoom way far out, it looks like x minus 1. Do you know how to graph x minus 1? Y equals x minus 1? Yes, you do. Y-intercept there, right? Up 1 over 1. So I have a slant asymptote right here. Eventually I'm going to approach and look like that. Okay? Now, we know as x approaches, we're going to approach this eventually. As x approaches 3 from the left, we go to positive infinity. So my graph is going to be up here. And then it's going to go past through that point, and then it's going to approach that one. Okay? And as I approach 3 from the right, I go to negative infinity. So I'm going to go to negative infinity here. And I got to approach this eventually. So that's a slant asymptote. You'll get an asymptote that's slanted to the side. We're going to approach it, keeping our same rules. Okay? In terms of horizontal asymptote, or vertical asymptotes and intercepts as well. Okay, and the y-intercept is 5/3, which is 1 2/3. Is 1. Fantastic, right there. Okay. All right.